Let's take a quick detour into the math, because mastering this logic is key to leveling up as a top-tier Python developer. You have likely seen big O notation before, but you might still wonder what it actually means and how to calculate it. Let's break it down with a clear example. Imagine we have a list of items. If you iterate through these letters A, B, and C and print them one by one, you are essentially making a single pass through the entire list. In big O notation, we represent this as n to the power of 1. But in practice, we usually simplify the syntax. We don't actually write out the power of 1. It simply means if you have 3 items, 3 times 1 equals 3 total operations. Now, watch what happens when we run this. You see the output: letter A, letter B, and letter C. But what if we loop through the items twice? Notice the change when I run the code now. We start with the letter in our outer loop. Then, in the inner loop, we repeat the process for A, B, and C. It creates a pairing. You get these combinations: against A, against B, and against the letter C. Then it moves to letter B and repeats the cycle for A, B, and C. This pattern continues through the entire list. Essentially, you have 3 operations for the first item, 3 for the second, and 3 for the third. That's 3 plus 3 plus 3, which equals 9. In shorthand, that is n squared. It means you are multiplying 3 by 3. Because for every item in your list, you are running another full inner loop. That gives us 9 total steps. That is quadratic complexity. So, how do we reach cubed? Mathematically, it looks like this: 3 times 3 times 3. That is what cubing actually signifies. We know 3 times 3 is 9, and 9 times 3 is 27. When you have this structure, with an outer loop and a second nested loop, just like before, but now we add a third. Can you imagine the scale now? Look at the results. We have generated a massive list of operations. If we were to count these manually, and I'll just paste this into a new window to show you. How many lines of output do we have? Exactly 27. And remember our math? 3 times 3 is 9, and 9 times 3 is 27. That is n to the power of 3 in action. 3 levels of nested repetition. That is the essence of big O notation. 27 total operations for just 3 items. The notation continues to scale this way. If you added another level of nesting, it would become n to the power of 4. 4 levels deep means even more complexity. 2 levels is squared, 3 is cubed. And with no nesting, it's just linear time. This applies to any number of items. If you had 4 items instead of 3, the linear version would just be 4 steps. But n squared would be 4 times 4, 16 steps. And n cubed? That's 4 times 4. Times 4 again, which skyrockets to 64. I hope this demystifies how these notations directly impact your code's performance. If this explanation made a click for you, don't forget to hit like and subscribe.